Hey everyone, it's Justin again. In the previous lesson, you learned about two ways to describe the slope of a line. Its direction and its steepness. And we even saw numbers being used to describe these two characteristics. But where do those numbers actually come from? And how can we find them ourselves? In this lesson, we're going to learn how to calculate slopes ourselves using a graph or coordinate plane. In order to prepare for this video, it's really important that you complete the GeoGebra activity in your PDF. If you haven't done so already, follow the link to the GeoGebra activity. Read and follow the instructions carefully, and spend some time exploring so you can answer the questions on your PDF. And helpful hint, if you're ever exploring and moving around points on a GeoGebra and you get kind of lost in your own work, you can always reset it by clicking on the reset icon. So, pause the video now and make sure you're feeling confident in your GeoGebra slope exploration before moving on. Now that you're ready to continue with this lesson, keep this GeoGebra handy. It'll be a great resource to come back to and revisit once you're more confident in your slope calculating ability. I'm going to start off by teaching you how to calculate the slope of a line from a graph. Let's analyze this line so I can show you how to find the slope of it. First, from what you learned in the previous lesson, what can you tell me about the direction and steepness of this line? The direction is positive since the line is going up from left to right, so we know the slope will be a positive number. And this doesn't look terribly steep, like if it were a hill we needed to walk up, so the number is likely somewhat closer to 0. Now that we have an idea of what kind of number our slope should be, let me show you how to calculate it. To calculate the slope, we need to find the rise of the graph and put it over the run of the graph. The rise is how much the line moves up or down from one point to another, and the run is how much the line moves left or right. This is also known as the change in y over the change in x. Notice this triangle symbol is a shortcut way to write change. I'm going to show you what all this means using this line to the right. Before we use the formula I just showed you, though, the first step is to identify 2 points on the line with x and y values that are nice whole numbers, or integers, rather than decimals. This graph has quite a few for us to choose from. Notice that these x and y values do not contain decimals since they are on the grid marks. We won't always be able to avoid decimals, as you'll see later in the course, but whenever possible, this is the best route to use. We really only need 2 of these points to find the slope, so I'll go ahead and pick these 2 for us to use. The second step is to find the change in y over the change in x for these 2 points. To do this, I like to go from left to right. I count to see how much the y value changes and how much the x value changes to get from the point on the left to the point on the right. The y value goes up 4 units. Do you think moving up 4 would be considered positive 4 or negative 4? Moving up in the y direction is considered a positive change, so we can put positive 4 as the change in y in our fraction. Then we can count how many units x changed by. We moved 6 units to the right. Do you think a move 6 units to the right would be considered a move of positive 6 or negative 6? A move to the right is a positive change in the x direction, so we can put positive 6 as the denominator of the fraction. Then we can move on to the final step, which is to simplify the fraction if we need to. Can 4 over 6 be simplified? It can. If we divide the numerator and denominator by 2, we get a reduced fraction of 2/3. Now that we've found the slope, let's use what we learned in the last lesson about direction and steepness to make sure our answer seems reasonable. 2/3 fits very well within the values we determined to be reasonable earlier in the lesson, so we can be confident in the slope that we found. Now, I told you earlier that I like to go from left to right when you're finding the slope, but you don't have to. Can you calculate the change in y and change in x to find the slope when going from the point on the right to the point on the left? Your work will look different, but the line hasn't moved, so the slope should still simplify to 2/3. Pause the video now and try calculating this slope again, but by moving down and to the left instead. In the y direction, we have to move down 4 units. What number do you think would represent going down 4 units in the y direction? Going down represents a negative change in the y direction, so we need to use a negative number. This is why I'll put -4 in the fraction as the change in y. And our change in x is moving to the left 6 units. How do you think we represent moving to the left for the change in x? Moving to the left is a change in the negative x direction, so we'll need to use a negative number to represent it. In this case, -6. Now, can we simplify this fraction? A negative number divided by another negative number gives a positive result, so we can start by getting rid of the negative signs. If you're curious about why we can cancel these negative signs, check out the explanation about this on the first page of this lesson's PDF. Anyways, this takes us to the exact same place we were before. We just need to divide by 2 to finish simplifying this. And that is how you calculate the slope when you have a line on a graph. Are you ready to try it? I'll be here to help if you ever get stuck. Let's give it a try with 3 example problems. Our first example says to calculate the slope of the line shown. Do you remember those steps I showed you earlier when I was first explaining how to find the slope from a line? If they're helpful to you, go ahead and use them here. Try to figure out this slope all by yourself. Pause the video now. There are already 2 points marked on the graph for us to use, so step 1 is complete. We can move on to step 2. We need to calculate the rise over run, also known as the change in y over the change in x. Which direction did you choose to move to calculate the change in y? Did you go down 10 units? Or up 10 units? If you went down 10 units, you'd also have to move right 2 units, giving you a fraction that looks like this. If you chose to move up 10 units, then you would need to move to the left 2 units, creating a fraction that looks like this. No matter which route you took, you have accomplished step number 2. We can now move on to the final step, simplifying the fraction. It's not proper math grammar to leave a negative sign in the denominator of a fraction. So, although these fractions each are representing the same number, I'm going to move the negative out front on both of them to be consistent and have good math grammar. The fraction that had the negative sign in the numerator didn't necessarily need us to move the negative sign out front, so if you left the negative sign in the numerator, that is totally fine too. Now that we've taken care of the negative sign, what else do we need to do to simplify this? We can divide the numerator and denominator by 2, and this gives us -5 over 1. Now you might be wondering about this 1 in the denominator. Isn't a 1 in the denominator just extra to write for no reason? Yeah, writing -5 instead means the exact same thing and is simplified as much as possible. Now that we've finished calculating the slope of this line, let's take a moment to just stop and make sure our answer makes sense. After all, the previous lesson about slope, direction, and steepness was intended to prepare you for this lesson. I wanted to make sure that you'd have strong reasoning skills so you'd be able to make sure your answer seems reasonable and catch any silly mistakes. So, does -5 seem like a reasonable slope for this line? The line is going down from left to right, so the slope must be negative. And it seems fairly steep, so the number probably isn't that close to 0. So yeah, I think -5 is very reasonable. Here's another example to try. You may be wondering what's going on with this example because the line shown on here is horizontal, which is something that we are not super familiar with. So you'll have to trust me when I say that you can calculate this the exact same way we have been. Calculate the slope using the same approach and see what you can come up with. Pause the video now. Did you choose 2 points? You probably didn't pick the same points as me, and that is totally fine. If we both do our work correctly, we'll get the same answer anyways. Our next step is to calculate the change in y over the change in x. So how much does the y value change when going from one point to another? It doesn't. The y value stays the same. We can even verify that by looking at their coordinates. The y value does not change. So that means we put a 0 for the change in y? Yeah, that's exactly what it means. Your change in x is probably different than mine depending on what point you chose, but my change in x would be 6 units, or -6 units depending on which direction I went. I'm going to use +6 as my denominator here. Okay, so now that step 2 is complete, let's work on step 3, simplifying. How would you simplify 0 over 6? Well, 0 divided by anything is still 0, so we could just write this slope as 0. Now that we've simplified, let's think about the reasonableness of this answer. If this line were a hill you had to walk on, how difficult or steep would it be? Yeah, it doesn't have any steepness at all. So a slope of 0 makes perfect sense. And this is what the slope will be for all horizontal lines. One more example to try. Can you find the slope of this vertical line? Pause the video and try it without me. All right, let's see. Pick 2 points. Any 2 points, ideally on the grid marks, like these two, so there's no decimals involved. Then find the change in y over the change in x. I'm going to move from the point on the bottom to the point on the top, and this is a movement up 5 units, so that gives me +5 as my change in y. Remember, I could have moved in the other direction instead, from the point on the top to the point on the bottom and gotten -5 as my change in y. I just have to make sure that I move from the same point when calculating the change in x that I do when calculating the change in y. Okay, so going from the point on the bottom to the point on the top, what is the change in x? It's nothing. Since this line is vertical, it doesn't move left or right at all. So a 0 in the denominator. This may seem strange, but we've gotten step 2 done, and we now need to figure out how to simplify this. Have you ever tried to divide something by 0? The concept of division is like splitting something up into groups. If you have 5 of something, how are you going to split it up into 0 groups? You can't. If you have a calculator nearby or a phone with a calculator app, type 5 divided by 0 and see what it gives you for an answer. Pause the video and try it. My calculator gives me an error message when I type in a number divided by 0. And my phone's calculator app literally says, you can't divide by 0. So what are we supposed to put for our answer? I know, strange question. When this happens, we just write undefined. because the value of 5 divided by 0 can't be defined. This will be the slope of any line that's vertical. And now, we've completed step 3. Now you know how to calculate the slopes of lines that are on a graph using the rise over run, also known as the change in y over the change in x. Be sure to always check that your answer seems reasonable using what you know about slope direction and steepness. Now that you've completed the GeoGebra activity for this lesson, along with the video and guided notes, make sure you do the additional practice in the PDF to verify that you're ready for the online practice game. It's really important that you are 100% confident in your ability to calculate slope, because it's going to be used a lot in this course and in other math courses you'll be taking in the future. So be sure to revisit any of the tasks on this checklist again if you aren't feeling confident. Good luck with that, and I'll see you next time.